Welcome to this video. We're going to be talking about the transformations of functions. This aligns with IXL Precalculus B1 and B5. So sometimes we need to tweak our functions to better model a certain situation. For example, look at the graph below. The dots represent height versus weight of a large sample of people. Now, which function of these two lines models the data better? You can tell that these functions have the same slope and they practically are identical except for the fact that this one's higher than the other one. And you can see that, of course, the top function passes through the dots better, so it models the data better. But it's really almost the same as the bottom function, except for a small tweak. So that's what we're going to be talking about. How can you transform a function in a small way to make it better fit a certain data set or a situation? The first type of transformation is called a translation. So you can either shift up or shift down, left or right, which we're going to talk about in a second. So if you have a constant added onto the outside or subtracted on the outside, that will shift it up or down. So you notice the red one is the original function, and then the dotted blue one shifted up. And here the red one is the original, and then the dotted green one shifted down. So the second part of the translation is a shift left or right. And this is actually, it seems like it's backwards. If you add a number on the inside of the parentheses, it will actually shift it to the left. So here's your original, and then this one was shifted to the left. And if you subtract on the inside, here's your original, it will shift to the right. The next type of transformation is called a reflection, and you can reflect over the x or the y-axis. So to reflect over the y-axis, which is the one going up and down, you change the x on the inside to be negative, or really just change the sign. And so here's your original function, and then it's reflected over the y-axis to give you this one over here. Similarly, for over the x-axis, you can put a negative or change the sign on the outside of the function, and it will flip it over the x-axis. So this will go and flip down. So the final type of transformation is called a stretch or a shrink. So this one can get a bit confusing. You can do a horizontal stretch or shrink or a vertical stretch or shrink. So let's start with horizontal. Horizontal deals with a number on the inside. So if the number or a constant multiple on the inside is bigger than 1, it's actually going to shrink it. So here's your original function, and then on both sides of the x-axis, it's shrinked inwards. And with the stretch, the only difference is that a is less than 1 but bigger than 0, meaning it's not negative. So you're thinking like 1/2 or 1/3 fractions. And that's multiplied on the inside, is actually going to stretch it. So here's your original stretched out in the horizontal direction. Then you've got your vertical stretch and shrink. So this is actually the opposite of the horizontal. If you're multiplying on the outside of the function and it's greater than 1, that will be a stretch. So here's your original stretched up, your original stretched vertically. And vertically can also include down. And then if a is less than 1 but greater than 0, it will vertically shrink it. So this graph will shrink down, and then here it will shrink down. A vertical shrink looks a lot like a horizontal stretch, and a vertical stretch looks a lot like a horizontal shrink. So it can be confusing. Let's try some practice. For each of the following, describe what the transformation does. So here we have f of x goes to f of x minus 5. So since it's on the inside, I know it's horizontal, and it's going to be a shift, but is it going to be left or right? So horizontal shift, it's actually going to be right because negative on the inside means to the right. So horizontal shift right. On this next one, two things are happening. First, there's a number being multiplied on the inside, and there's a 3 onto the outside. So the number on the inside is going to be a horizontal stretch or shrink. Since it's bigger than 1, it's going to be a horizontal shrink. And then you've also got a vertical shift, and it's going to be up. So positive 3 on the outside. So on these questions, we're asked to find g of x, where g of x is after the transformation. So in the first one, it's translated 1 unit left and 3 units down. So 1 unit left would be x plus 1 on the inside, and then 3 units down would be minus 3. So I want to change my function here to look like this one. So I'm going to do 6, and then I would do x plus 1, and then plus 5, not plus 3, but minus 3. This will simplify to 6, absolute value of x plus 1, plus 2. Let's try another one. Find g of x where g of x is a reflection over the y-axis. So reflection over the y-axis will go from f of x to f of negative x. So we can fill that in, and that would be 2 negative x plus 4. And on this one, it would be 2 negative x plus 4 squared. Now I did these ones specifically because since this absolute value and this squared are as they are, you can actually flip the direction or the order of negative x and 4, which you will see on IXL. So this becomes actually 2x minus 4 and 2x minus 4 squared. And these are equal to the ones before because the fact that absolute value is always positive and square is always positive. So I mentioned that because you need to look out for this on IXL. Let's try this last one. We're given a graph and we want to find the equation after transformation. So this is the original f of x equals x squared, and we notice that this one has been shifted to the right and down 4. So let me write that out. Shift right 1 and down 4. So I know a shift right 1 would be actually negative because it's opposite on the inside, and then down 4. So I'm going to change f of x equals x squared to reflect that, and it would become x minus 1 squared minus 4. So this is my new function. And that's it for this lesson. Go ahead now and try some practice on your own.